and I'm going to introduce Dr. Rachel Smith, who is one of our astrophysicists at the Museum of Natural Sciences. She's the head of our Astronomy and Astrophysics Research Lab, and she is also a professor at Appalachian State University. So Rachel, without further ado, I'm going to hand it over to you.
All right, thank you, Carrie, and welcome everyone. It's a great big group tonight. That's awesome. So I hope you're having a great week and weekend of astronomy days. So I'm here to introduce my colleague and good friend, Dr. Dan Caton. And Dr. Caton, if you've come to a number of astronomy days, he has been a faithful and loyal participant and blessed us with his wonderful presence and presentations in science over the years since I've started. In fact, he's one of our greatest supporters at the museum and also a colleague in the Department of Physics and Astronomy. And tonight he was going to do some remote observing for us, but whether we, as astronomers, we can't really control the weather as much as we try. As much as we really thought Dr. Caton would control the weather for us, he didn't, he failed. So, so he's going to give us a really awesome discussion about his science, and it's going to be great. But just as a brief introduction, Dan Caton got his PhD at the University of Florida, Gainesville. I don't have a year on here, but it was probably before they kept yearly records of the actual year. So I'm kidding. But he graduated with a bachelor's in 1973. And then he went on to University of Florida, Gainesville for his PhD in astronomy. He's been at Appalachian State for several decades and was one of the first astronomers in our department in physics and astronomy. He's also the director of observatories, and the image you see behind Dr. Caton is one from a public observing night, Dark Sky Observatory, which I saw in the chat. At least one of you have been to, up in the mountains of Boone, which is really an awesome place with a 32-inch telescope that he'll tell you more about. His area of expertise is the study of binary stars, which are pairs of stars that orbit each other, which is actually very common in our galaxy. So he's going to tell us about those. And he was the founding president of the North Carolina section of the International Dark Sky Association. So he's a big proponent for keeping our skies dark, which astronomers need to see stars and other really cool objects up there. And so we're getting less dark as we evolve more, have more technology. And so it's going to be an ongoing problem, probably a growing problem unless we do something about it. So Dr. Caton is an expert in that to reduce light pollution. He's not a proponent of pseudoscience. This is in his bio, so I'm going to state it. He debunks pseudoscience as a good scientist should. And he investigates claims of the paranormal as well. So he's got these dual interests. So you might want to ask him what that's about. And he's been on various specials on television. So I think that's about a good introduction. Without further ado, I will hand it over to Dr. Caton. Thank you.
Thank you, Rachel. Yes, Rachel's been a good colleague and a good friend ever since the museum and Appalachian State in a joint arrangement hired her, and it's just been a fantastic experience ever since. So yeah, as was mentioned, the weather's not playing well with us, so I'm gonna kind of do what I can. I'm gonna mix it up. I'm going to actually control a telescope remotely and show you how we observe. I'm going to show you some recent images we took on a public night that was clear, some images from my research, and I'll talk a little bit about my research. We'll just kind of mix up a bunch of things. And I really want, I invite you to post questions in the chat that will get fed to me. And you can drive the conversation, because I'm in a boat with only a partial rudder for reasons I'll show you in a moment. In fact, I'm going to go ahead and share my screen. So here's the first problem is we have, this is a radar map, and this pink and purple is snow. I live a little bit outside Boone here. Our observatory is right over about here on the Wilkes-Ashe County line. And so this has been forecast for several days now, and they were right on this one. So there's nothing much I can do about that. So I came up with plan B, yesterday morning, and that would change to plan C. So plan B was I'm going to connect to the 32-inch, and I'm just going to steer it around and show you the dome moving and explain how we do things. So that was my plan. And then last night when I got home for some activities, I found emails from my colleagues saying, we lost internet at 1:50 p.m. So here's the view of our webcams. So we have webcams out there that look at all the telescopes, including the campus telescope, and the 4 quadrants of the sky, and a couple of all sky cameras, fisheye views of the whole sky. And this is how it was at 1:50. And I called the phone company that provides our internet via, we have fiber optic out there in the sticks, believe it or not. They said that there was no general problem. I text messaged a neighbor of the observatory, and she replied that no, we have internet. So it's our equipment. And my observatory engineer chose this weekend to go out of town. And a colleague of mine who had the telescope for last night just to get data. I mean, we just will not let a good sky go by, right? So he drove out for the night and observed old-fashioned style at the observatory, which, believe it or not, is old-fashioned. We don't generally do that. I'm going to show you how we do it. And he rebooted the router, and that didn't fix it. So it's some interface box between us and the phone company out there, and they're not going to be able to service that till Monday. So I won't be able to really use this telescope. This is the one I was going to use. It's pointed at the zenith part there. It's got a spectrograph on it. My colleagues are spectroscopists, and I do other kinds of work. And so it's equipped for that right now, and it's pointed at the shutter that's closed. And I can't do anything with that because I can't connect to that. This server that feeds all of these is the university servers, and our equipment, our computers push these images to that. And that's the sky as it was yesterday. And so we're going to use, but then it occurred to me this morning, as I was awakening with a little gloom, I was thinking, what am I going to do? The campus telescope is very similar, and I can connect to this. So I'm going to drive this around a little bit to give you a feeling for how we observe, and show you how that goes, and then I will look at some images and some other stuff. And
so Dan, we have our first question.
Yes.
So a friend is asking, how expensive are the telescopes you use?
Okay, this telescope here on campus is 16 inches in diameter. It's not exactly an amateur quality instrument. It's sort of a low-end professional instrument. We got this about the year 2000-ish with an NSF grant, and this was about $85,000. So it's more expensive by a factor of 2 than an equivalent amateur grade instrument. The 32-inch we got in 1995, again, 1/3 of it paid by the NSF, 1/3 by the state of North Carolina, and 1/3 by the private ASU Foundation. And that's how you have to do these big ticket items. This was $325,000, I think, with tax. Yes, we got to pay tax because back then they had not figured out, why are we taxing ourselves? So we were one of the last big purchases where we paid sales tax to the state of North Carolina. A few years after that, they did away with that in their wisdom. And so, yeah, so this is probably close to $500,000 now. Both of these are made by a small company in Longmont, Colorado, near Boulder. And that's what they do, is they make 1 meter to 2 meter class telescopes. So this is a substantial instrument. It can carry large loads, and so it's a much more robust thing. It has a bunch of auxiliary finders and extra telescopes mounted on it that I'll mention a little bit later.
And so
Okay.
Tanya Oh, Tanya wants to know, how large are the telescopes on Mauna Kea in Hawaii compared to these?
Oh, they're giant. This is not big. This is typical of a university campus or university local telescope. Telescopes, so this is nominally a little less than a meter, 0.8 meters. The telescopes on Mauna Kea are like 10 meters, 8 meters, 10 meters, really big glass. And Dr. Smith uses some of those. She has access to Keck, which has a 10-meter mirror, a segmented mirror equivalent to 10 meters. And there are other large telescopes on Mauna Kea. If you're building a national instrument that's going to be used by lots of people, you don't put it in the mountains of North Carolina, where we'll get maybe 200 usable nights a year. You put it out there where you'll get 350, even in Arizona, 350. New Mexico has good skies, California. That's where you find historical development of astronomy. And of course, in the Southern Hemisphere in Chile. So that's where you find, where you put big telescopes so you get the maximum use of them. Okay. So yeah, so that's our situation. We're not going to let this stop us from playing around. I'm going to connect to this telescope here, and I'm going to show you how I do that. Let me bring up the control system. So now I've connected my computer to over the internet to the computer in that dome that controls that 16-inch telescope on campus. We use a nice app called VNC, Virtual Network Computing. If you ever have a need to control a computer that's not at your, it's your work computer or your home to work, or whichever way you go, VNC is free. It runs on all platforms. I'm running Windows, but it runs on Macs. It runs on Android and iPhones. I've started observing runs many a time from places that I will not reveal. Maybe I shouldn't have been doing it, but I was there and I had to start my run from my phone. I open up the dome, I get the telescope pointed, I start the data acquisition going, and I'm good. So it's a wonderful app, VNC, and it's free. And so I've connected to that computer, and I could click shutter open. That would be a tragic thing. And actually it won't do it because it knows the weather is cloudy. And if the weather is very cloudy, it will not open even if I tell it to. I can override that with this disable cloud sensor button, but you don't want to go there. But I have to, because it'll also won't open if it's twilight skies, and I have to take calibration images of the more or less evenly illuminated dusk sky. That's too bright to let it, so then I have to click that and I can open it and do my calibration images, my flat fields as we call them. And so I can, I'm going to bring up connect to another computer there, here. So this is a computer that has some control functions too. So I can, and this is the sort of the live view of that webcam. So like if I turn off the lights, then yeah, went dark. Okay, let me turn it back on. Okay, and so I can I'm going to just steer the telescope around a little bit to show you what you can do. I'm going to turn the scope motors on. Okay, so I powered up the motors that control the two axes of the mount. And now I'm just going to slew it around. I'm going to go south. This fork mount, this axis of the mount, telescope mount, is tilted at an angle for a good reason. It's pointed at the North Star. And so when you find a star by moving it in both axes and get it on that star, then a clock motor in here tracks to counteract the Earth's rotation. The stars rise and set, just like the sun and moon do. So you have to track those. And so anyway, so you point one axis to the North Celestial Pole, as we call it, and then you only have to track it around that one axis, which simplifies things. Now, big telescopes like Keck point this fork vertical because the engineering is a lot easier than tilting this over and putting a load like that. But they have computers that can track simultaneously in both axes. And so that has opened up a world of better computers. I think the first large telescope that was of that type was the Soviet 6-meter. And that was the dawn of computer affordabilities when they did that. And since then, all of the big telescopes are on alt azimuth mounts where the fork points up to the zenith and you go around in altitude and azimuth. Anyway, so I've turned on the motor and I can slew it. I'm going to slew it south, which will be over to the right here. So I'm going to go over to the control computer. I'm going to press the south button and there it goes. And I could go west too. I could go west some. Okay. And so that's the basic tube and imaging cameras on the back. And so this is what we use to teach intermediate level astronomy courses, observational courses, photometry courses, and other things. I can actually do it another way. I'm going to go ahead and turn on that tracking. Why do you got to turn on the tracking? You don't need a tracking. You can't see a star, right? Well, the operating system is going to be a little unhappy if I go to a moving object and it'll never get there. It'll think it's not there because it'll get there and oh, it's moved, and it'll actually try to track with the normal motor operation. That's not good. And then I'm going to show you the other way we do this. This is the telescope data acquisition computer. And he looks at it with some surprise and a pause in his voice because, okay, so this program here, what I was going to use is the Sky. And it talks to the telescope control computer and it's really cool. And this morning when I looked, this wasn't running. And this not connected to it, not connected. And I tried to start this and I locked up the computer. And I tried to fix that. We have internet controlled power strips. And I went over here and I said, shut off the data computer, switch off. It asked me if I really want to do that too. And I powered it off because it was plugged into this power strip and socket number 1. And I turned it off and I turned it back on and I could not connect again. So I drove into campus this afternoon and yes, so it had booted up, press F1 to continue. My observatory engineer, I texted him, he thinks it's the motherboard has a battery that keeps its clock and everything when you're not turned on. And he thinks that has worn out, you know, it's depleted. All computers have a little board, a little battery on the motherboard. So let's wreck it again because I can't do this unless it runs. And maybe it'll run, but I doubt it. Let me make sure it's not already running. For you Windows, yeah.
We have a clarification question. So Philip wants to know, does shutter open the dome, and wants to know if that's why it stays closed when it's cloudy to protect from the weather.
If what exactly is the question now?
Does shutter open the dome so it stays closed when cloudy to protect from weather?
Oh yeah, we keep it closed all the time except when we're observing. Does that answer the question? I have to click shutter open and then it opens, which I'm not going to do tonight.
Right.
I'm going to, so you Windows fans, I can send a Control-Alt-Delete with VNC and I can start the task manager. A little interesting lesson. And my question is the Sky already running? And I don't see it running, so I'm not going to start a second instance of it. So let's wreck it. Okay, yeah, let's wreck it. I'm going to click on this and see if it runs. And it actually runs. Okay. And I'm going to connect it to our telescope link, establish. And it should be a little red, a little white, some colored cursor. It should be right at the zenith, and it's not. And I don't know why it's not. And when I did this afternoon at the observatory, I had that same occurrence. Let me view reference lines. So this thing closed itself. This is not a good sign. This is not something that should happen. Okay, so there's the, oh, that's right. It's not pointed to the zenith anymore. I got it off. So now if I suppose I was going to, if we could actually observe what I can do in this program, the sky, which is a lot like Stellarium, which is free, but this isn't. I can click on a star like this guy here, and it brings up the information. And I hit some random faint thing. I didn't actually hit that bright guy. If I click this little slew button, we're going to see the telescope go to that star. It's going to make sure I really want to go. Okay, it's a second level. Do you really want to do this? And at the observatory, we're doing it in the control room. On a night we're actually there, where the control room is 25 feet from the dome. And at this point, I yell out, "Clear!" And I don't mean the sky. I mean, am I going to kill anybody? You know, is somebody up on the ladder, you know, at the eyepiece? And so, no, nobody's there now. So if I click OK, the telescope's going to move on its own here, he says. There it goes. It's not going to go real far because we didn't go very far. So now if the dome were open and it was clear, we would be pointed at that star. So that's one way we can do it. This is a kind of a handy way of doing it. And I don't know why this box is not going off. Well,
so, Dan, a few people are asking if you can make what you're showing us any bigger. I think folks are having a little trouble seeing it.
Yeah, that's always a problem. I mean, I can't really make things much bigger, and I don't know what it looks like on your.
Don't break the telescope, Dan.
Well, I won't break the telescope, but I don't know what it looks like to you because I'm not there, and you know I've got a full screen with all this stuff on it. So I don't know. I can't do much. Okay. So now I'm pointed down here, and why that slew didn't seem to complete, I don't know. But let's see what this guy here thinks. Oh, I didn't turn on the tracking. Yeah, I did turn on the tracking. There, it's on. Oh, yeah, but we have a problem with this. Yeah, it wasn't tracking at the sidereal rate, and we don't know why that is. That's another bug that's popped up, that when we park the telescope, it zeroes that. And so now if I go to my slew movement here and slew position, I don't know if I want to do that. Well, I'm not going to do that. So anyway, I'm gonna go ahead and park the telescope at the zenith. So I'm going to set the zenith position. That's going to put the destination up here, and then I'm going to say start slew, and it's going to point. It's going to go back and point to the zenith. He says, "Oh, except it won't, because I didn't turn off the tracking." By the way, for my fellow moderators at the museum, I'm getting these admit a new person, and I've been saying admit. Do you get
yeah,
those?
actually, yeah, Hugo's in charge of doing that.
Okay, I didn't know why I was seeing them.
Yeah, it's because you're a co-host. So in Zoom,
okay,
all the co-hosts are going to see it. But yeah, just let Hugo do it, because what happens sometimes is if more than one person do it, he can accidentally mute you. So we always have, I'm sorry, I didn't mention that, but yeah, only one person that admits.
I'm parking the telescope, and I had to turn off the tracking because otherwise it will never get to the zenith. It will get there, and then the tracking will move it off, and it'll say, "Oh, I got to move it again," you know. And so it's kind of confusing there. So that's how we do things. And when I'm observing, I do imaging of eclipsing binaries and other things, and I would point the telescope to my target. I would tweak up the centering by taking an image, which I can't do tonight, and I get it aligned like I want. And then I would start a sequence of images, and it will be, I've calibrated it to go all night or till the telescope's too low or whatever limits me. And I will make sure I don't have the cloud sensor disabled. Then of bad weather, I go to sleep. If bad weather comes in, it will close the dome. If otherwise, it'll go till dawn twilight brightness closes the dome. And so that's one thing I do. And then I set up a timer on the scope motors here. And it's hard to see this, but I can set up a timer so that it'll turn off the tracking of the telescope at dawn. So I'm all good. Telescope's going to stop moving, and the dome's going to close, and everything's going to be good. And then I sleep in, and I get up at a civilized hour, and I park the telescope back at the zenith and start my data moving over the internet to back to campus. So that's the kind of game we play. And by the way, this you might or might not recognize. Active Home is a home control system we use for some functions, and it's been around since at least '78. Because I remember I bought a BSR X10 controller back in 1978. It must have been one of the very first home control systems. It's still around. X10 went belly up. You can still buy their devices. I don't know, somebody's making them. In general, I mean, in patent law, if you go out of business, and others have free reign at making what you used to make. And so somebody's still making this stuff. And you can get the software, except getting that may be hard now. Although it's also beyond patent because it's probably out in the wild. And this sends commands to switches over the power wires, which is people are doing again, but this is way before Wi-Fi or Bluetooth or any proprietary radio signals. So this sends signals over the power wires, and then you have switches and wall switches and plug-in modules that you set to be a certain address, and then you name them what you want to do, and you can turn things on and off. So I'm done with moving the telescope. I'm going to turn off the scope motors.
So Matt has a question.
Yeah.
So he asks, what is the accuracy of the pointing model? Is the object you're looking to observe always dead center in your field of view?
Good question. I wish it were. No, it's not. And it depends on the telescope. The pointing lately on this telescope, the student telescope's been pretty good, probably to half an arc minute. So, 1/120th of a degree. The field of view is like 12 arc minutes on this telescope, so it's pretty dang nice. Oddly enough, last weekend when I was pointing the telescope at the 32-inch at objects for a public event, I repeatedly had errors of half a field of view, and I don't know why, and I need to discuss this with my observatory engineer. I'm wondering if in that telescope, whether the position encoder is slipping. Something is slipping, and so this telescope isn't driven by a big worm and wheel gear as we used to do. It's inside this is a big disc, and it sits on two rollers, and one of them is the motor that moves it, and the other is the roller that drives the position encoder. And that way, if the motor slips, it doesn't matter if this guy, but this guy may be slipping. So pointing precision has been kind of crazy on the 32-inch lately. The way you get it going for the night is to put it on an object of known position, center it up, and then you can go into, you can open up the telescope initialization menu, and you can get it centered up and say, here, telescope position, say, use next object position, which is what you sent it to. You send it there, but it's not there. You tweak it up with a paddle, and you you click that and then apply, and it resyncs itself to the sky. Okay. And if you're interested in getting your own telescope, by the way, for this freebie in, I had a colleague who wanted to get a telescope for his daughter for her birthday last spring, and I recommended this one. So you can get a telescope that's about 4 inches in diameter, about a foot long. It's on a mount with motors and encoders and a computer, and you do that same thing because it's not bolted down. You set the tripod up in your yard, so you got to sync to the sky every time you use it, right? So you get it out there, you adjust the bubble levels on the tripod to get it level. It remembers the time and date and your latitude and longitude, which you enter once. It remembers that forever. And then you point it. It provides you on a control panel with a list of targets to go to, and you go to a bright star and you get it tweaked up, center it, you tell it, oh, you're there. And now it's synced to the sky. And now you pick from a list of hundreds of objects, including planets. It computes the position of the planets that night. And it just goes over to it. It's really cool. Forget the $100 thing at Walmart. With all due respect, you can find the sun. Don't look at the sun though. You can find the moon. You can find Jupiter, Saturn, Venus, a bright star or two, and that's it. Anything faint and interesting, you could see it, but you can't find it. And so these so-called go-to telescopes are really cool. And I had people asking me for that advice in Christmas, and I discovered that they are either unavailable or 3 months behind shipping, or they're outlandishly expensive, like the $400 or $500 thing that my colleague bought. I looked on Amazon the other day, it was $1,280.
And I've heard, we're stuck at home, everybody's looking at the sky.
Yeah, and I've heard rumors there's a bunch of lawsuits between Celestron and Meade, and there's COVID problems, and the manufacturers can't get supplies from China, and then the West Coast shipping is a train wreck because of COVID. There's just multiple problems. So the bad news is you can't get one right now. Well, I guess if you pay that $1,280, you can get it from Amazon.
Well, that's part of the Raleigh Astronomy Club, and so they actually have telescopes that you can borrow. So that's pretty cool.
That's cool.
But, yeah. So, but cool. He has a follow-up question, and I apologize to both of you if in somewhere in your answer you answered this and I didn't understand. But he's asking, do you use plate solving to correct?
I don't, but a colleague who has a little telescope that. Well, he does it two ways. He has a little 6-inch telescope that he monitors young solar analogs. Those are young stars like our sun, solar analog, but younger than our sun. And he monitors the brightness with this little automatic system, and I think it does a plate solution. And then the spectroscopists, they also go to sleep. They have an automatic program that finds their targets all night, and I think every time it goes to a target, it does a plate solution. So a plate solution for you who don't know about this means you got an image of a bunch of stars and it's off a little bit, and you know what it should look like, and the mathematics figures out how much you're off, and then can correct the telescope position. Every now and then we'll do something dumb, and like have the telescope control computer will go south when you're not pointing at the zenith and the dome's not west, which is what the code expects when you reboot it. And now you're way out. And you can take an image of anywhere in the sky with any telescope and upload it to a service called astrometry.net. Astrometry is the art of science, star positions. And that service will take it, no fee, and it will figure out where you are looking in the sky. It doesn't need to know the scale of the image, the north-south orientation, mirror flips, anything. It'll find it in a few minutes, which is amazing. It looks for it picks the three brightest stars. It looks for that pattern in an enormous database. And it really is pretty cool. So that's another example of plate solution. That saved me on more than one occasion. So
So cool. So Connie has a question.
Yeah.
So going back a little bit to what you're talking about,
Yeah.
they're asking how long did it take to build this telescope? Because we were just talking about the manufacturing woes.
These telescopes, you mean? The ones I've shown you? Well, the 32-inch, that telescope took a little more than a year. You know, a small company has 5 or 6, 7 employees, machinists, you know, techies, engineer, the owner, the secretary. Small companies, they don't exactly put these on the shelf. They're built to order. And so when we ordered this, I wish it were as simple as I would just call up Frank Melsheimer, this DFM Engineering is Dr. Frank Melsheimer, the owner, and just say, Frank, build me one, you know. But purchasing things in North Carolina doesn't work that way. So it took months we had to go out on bid, and the only other bidder was Zeiss out of Germany, and they just bid some enormous amount of money. And so DFM got the contract and they started building it. And actually, gosh, the state of North Carolina engaged an attorney to protect our interests in Colorado, apparently the most expensive attorney in Colorado. And we had to have a lien placed on them while they were building it. This is silly business things that, you know, just waste everybody's money. But they built it to price and delivered it, and they installed it. And so on the order of a year for anything, even the 16-inch, you could get probably in a year. And a dome takes about a year. Because again, these are small companies. There's like 2 companies in the US that build astronomical domes of professional quality, not the little fiberglass thingies. And so it takes a while to get that. But they will build it to your specs. And in fact, they didn't used to do the mirrors. It has the reflecting main primary mirrors behind this bottom plate in this cylindrical bottom section. When we got it, there was a delay waiting for another company to deliver the optics. And since then, DFM just set up its own optics fabrication. They make their own mirrors now. They got tired of third parties not delivering. And so they make everything, and then they send the mount out for a nice paint job at an auto body shop. I mean, who paints big chunks of metal better than an auto body shop? Why have a painter on staff? You just take it down the road to the body shop, and they put a beautiful finish on it. And so
do you get to choose the color?
No, you probably could. This is DFM yellow. So if you see this in an observatory, it's probably, if it's 2 meters or less, it's probably a DFM telescope. There's a 60-inch that looks like this, big brother of it, and the U.S. Naval Observatory station in Flagstaff. So someone mentioned Flagstaff as being dark. Flagstaff is really dark. Flagstaff has one of the best light pollution ordinances around. I'm on the AAS committee on the American Astronomical Society Committee on Light Pollution, Radio Interference, and Space Debris. And Jeff Hall, the director of Lowell, is on there. Lowell Observatory is in Flagstaff. Lowell has a better site too out of town. But Flagstaff itself, I mean, they have very cool amber 2700 Kelvin street lighting. They are on the frontier of doing things right. So Flagstaff is a good example. Tucson's another good example. They've had a lighting ordinance for decades. The IDA started in Tucson to protect the Kitt Peak. Anyway, so what else do people want to know, or I can wing it?
So Tina wants to know if it's possible to come to your observatory and have a tour in real life when it's not COVID.
Right. Let me bring up my browser, which probably won't be big enough, but I'll pretend like it is. If you go to dso.appstate.edu, on the home page is the first paragraph is all about the next public night, except this isn't. This is about last Saturday because I haven't had time to set up the new event. And then there's a link at the end where you can get tickets. There's probably no tickets showing because all the events are over. So we had one last Saturday, went really well. And like tonight we had, had clear skies. And normally there'd be ticket options down here. And what a deal. $5. $5 for your whole freaking family. Whoever can view off your device for $5. I mean, and we actually have 10, 15, and $20 options for those who want to donate more. And some people do. And all of the money that we collect, we put back into outreach. And normally I would be hiring students. So normally we would be out there, you know, not with the bright light on. This is an artsy picture taken by a former student who's now an IT guy at App. Normally we would have people inside looking at things in the telescope with lights off in there too. This is the visitor center where we gather for an introductory PowerPoint, and then we do that. And we have a, not shown here because we got it after this. We have an additional 11-inch telescope we set up on a handicap accessible, electrically raisable pier that's bolted down here now. So we have an extra telescope for spillover, and we set up a card table out here with a handful of pairs of binoculars. Binoculars are really cool. You can see a lot. If you're not sure about that $400 telescope, get a good pair of binoculars. You can hardly go wrong for $100, $150. And you can see a lot. You can even see the moons of Jupiter if you can prop them on something to hold steady. You can barely make out that Saturn has rings, although you'll see them as Galileo's knobs. You know, he couldn't resolve the fact they were really rings, but they look like some kind of wings or knobs on the side. But you can see a lot, and a lot of star clusters and Pleiades and all the Orion Nebula, a lot with a pair of binoculars. So we have binoculars out here, and then inside we have some meteorites on display from our donor, Don Klein, on loan. And control room is in there. And we, this is a partial PowerPoint I just queued up. Here's our control room. Sadly, this is what it looks like now. Is the romance gone? That was my comment. We're all observing from home. You know, so is the romance gone? I once had a student, a major, who she asked, I want to observe. I said, I had to tell her, I'm sorry, Gabby, but you were born about 2 decades too late. But contrary to that, I've started a collaboration. We're in about year number 5 of observing eclipsing binaries with collaborators that come in from out of town, and students join us, and we do classic mode observing runs, 4 nights in a row, up all night. Go to bed at dawn, get up the next day, and do it again. And any student who's involved is on the resulting papers. In fact, let's visit a meeting where I gave a paper briefly. This is a virtual AAS meeting 2 weeks ago, and I can go to the iPoster gallery, and I want to view an iPoster, and I'm going to just quickly, there's my poster. And in fact, there's pictures of the students. And there's dawn. That's not sunset. That's dawn after we're about ready to drive down to the Lowe's house and crash for the day till noon. And there's a facility open in the daytime, a little artsy, painted with red flashlight view. Some more students. And any student who participates as these last 3 co-authors is on the posters and the papers. That's our rule. And
so Maria Clara has been asking if you could talk a little bit about binary stars. So I think this might be a good time.
Yeah. So we observed these binaries, and I can make that bigger. So this was a binary we observed. Let's see. We observed this last January. This was our last collaborative run. We couldn't do those once COVID started. You're not going to have a room full of unrelated people all night together. And so this was my star. This was a twofer. there are two eclipsing binaries in this field. So we got 2 papers out of this. I was doing DWCMI and my colleague, no, I did TXCMI. No, I did DW and he did TX. Anyway, so this was, these were variable, sorry, these are eclipsing binaries. They look at like 1 dot of light. All eclipsing binaries are so far away that you can't resolve them into their component stars. There's just 1 dot of light, but that dot of light changes brightness through the night. We observe systems that have orbital periods of about half a day. Can you imagine that? 2 stars go an entire orbit around each other in 12 hours, some of them 8 hours. And that means in a long winter night, you get a whole light curve. In fact, we got a twofer. And we repeat it so we get a better density of data. And anyway, so that was that. This was a couple of sample nightly light curves, and we had some gaps, and I would fill those in later if we couldn't complete that on our run. And so this is all the data phased together. We do it in 4 different colors: blue, V, which is the astronomer's word for green, visual. Historically, your eyes are most sensitive in the green, so it got named visual. Red and infrared, because this gives us temperature information. Oddly enough, our cameras are, you know, $30,000, $40,000, and they're black and white. What? My iPhone's better than that. Well, of course it is. Well, if you could take an old phone that you might still have somewhere and grind it apart and get down to that camera detector and put it in a microscope and look at it, what you'll find is that each of those millions of pixels, each pixel is an array of several pixels with little tiny color filters in front of them. That's the only way to sort out color information, is filtering. And so we use calibrating. That would be impossible. Millions of pixels that are you couldn't do it. But this way we have a filter wheel that rotates in these different colored filters into the beam. The whole image we take is through that filter, and that you can calibrate out. So we get the data, and then we solve it. So here is the model that fit the theoretical model. So you have computer code that you tell it the temperatures and sizes of the stars, and it creates a synthetic light curve and draws it among your data, and you tweak those parameters about those stars till it fits, and then you know the temperatures and sizes of stars. This is one of the few ways we get sizes of stars, is with eclipsing binaries. Here's the computer code's model. We had to put a spot in this to get the solution to work. That's pretty common. Other stars have big spots. This may be a spot group or an area of spots, but anyway, it's a spot that's accommodated in the model, and you put that in to make it fit certain areas where it wouldn't fit otherwise. And so then you're done. Then you know all about the stars, and here's all the parameters and everything. This was something I don't want to really get into, but so that's what I do. One of the other things I do quickly, and I'll just minimize this, is I look at when an asteroid blocks out a star. Okay, so these are events that take several seconds to happen, and if you can time it, then you can, knowing the orbit of the asteroid, you can figure out how big the asteroid is, how long did it take for it to go in front of that star and cover it and uncover it. But the trouble is our $40,000 dang it black and white camera is also slower than bejeebus. It takes 10 agonizing seconds for the image to come out to the computer. So you can't bang, 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 take images. What are you going to do? Well, you position the star at one edge of the image, and before, like 20 seconds before the event, I start the telescope tracking. And then I open the shutter for 40 seconds, and the star paints a line down there. And I think you can just visually see that's where it blocked. where it blocked out the asteroid blocked out the star. And in fact, after the fact, you can do this. I don't know whether I can do this accurately or not. So you can use software to do an intensity scan on that. And I'm going to do there's the intensity of that line. That's when the asteroid blocked out the star and it unblocked it. This was dark and then I opened the shutter, and the noise is just because you're not getting many photons when you're drawing a line like that. And then bang, the asteroid blocks it out. And I report to these to someone who collects them all and all of our observations and does the astrophysics of figuring out the size of the star. So that's another thing I do. Okay. Any other questions?
Yeah. So Mary Lou wants to know, is light pollution from Elon Musk's SpaceX satellites interfering with your telescopes?
Oh, don't get me started. So like 18, 20 months ago, that was off our radar. If you had asked anybody on the Light Pollution Committee, also radio interference, also space debris, it gets everything. We would have said, oh yeah, I think somebody's going to launch something or whatever. And then he launches those, and that's been our center of focus for the last year and a half. We've had meetings, we've had webinars where Elon, he attended one. Patricia Cooper from SpaceX is usually his rep, and it's going to be bad. Between Elon's, he wants 30,000 of these. There are other players in the game, including Amazon and OneWeb. You total it up, we're looking at probably 100,000 internet satellites. For an hour or two after sunset and before dawn, that's when the sun is positioned to light them up. You won't be able to take images without getting a streak in it. And this is the time when, ironically, the Vera Ruben telescope is about to open the next couple of years. It's a wonderful facility. It used to be called the Large Synoptic Survey Telescope, but they named it after Vera Ruben, who did wonderful work in dark matter, because it's going to investigate that too. But now they're calling it the Legacy Survey in Space and Time. That's because it is going to image the entire sky every night, and it will be done every 3 nights. Every 3 nights it'll start over. It's going to discover everything that appears, disappears, moves, or changes in any way. And this thing is going to see first light about the time that all of these satellites are on there. And Tony Tyson, he's not on our committee. He's the astronomer, head astronomer for LSST and Vera Ruben. And he's been participating. He's modeled it. It's going to be bad. One streak it won't damage the detection chips, but it will saturate them, and it will create bands parallel to it. It'll make a mess of any image that it's on. And so we're very concerned in our discussions. SpaceX seems sincere in working on it. They painted one of theirs as an experiment, or finished it black, and that made them dimmer. But the trouble is that sunlight made them hot, and electronics don't like that. And there's no way to cool things in space except by radiation, by just radiating heat away. And so then they came up with a very clever thing, and I think everyone they're launching now has this movable plate that comes up and blocks the sunlight, and that seems to have darkened them a magnitude or more. So we feel like they're sincere, but it's a business, and I don't know. I hope it fails, frankly. And he's charging he's rolling out beta receivers to certain people to test, and not cheap. It's like $500 for the hardware, and nobody can believe he's making money on that. And $90 a month for bandwidth that's maybe not even comparable to spectrum. So, you know, I don't know. It's a good question. And, you know, and their radio interference, to the radio astronomers, these are radio pollution sources up in the sky. So it's that, and then they have a finite lifetime and they need to deorbit them. And they do have a cradle to grave plan. I don't know exactly what it is, but they do have a plan. So we're all kind of disturbed by this. So.
Okay, well that was a sad note.
Yeah.
So that was a downer. All right. So Jocelyn has a question.
Okay.
Do you have access to telescopes outside the country, i.e. Chile?
I don't. My collaborator Ron Samick gets time on the Sarah. I think it's a 36-inch down in Chile. Sarah's the Southeastern Astronomy Research Association, or whatever. It's a consortium of several colleges, mostly in the Southeast, who run that. And he knows people and gets unused telescope time. And he gets some time on a similar instrument in the Canary Islands, off Africa. And I was looking for my shortcut here, and we used to get access to telescopes, small telescopes in Chile through Skynet. This is run by Dan Ruckart, who gave a nice talk today on SETI, actually.
Yes, we'll have the recording available tomorrow.
Yeah, and he runs that. We used to have, well, we have 2 telescopes that were on it. And right now they're not. And the reason they're not is that this guy, let's see, why is he not on it? Well, other than being cloudy. Well, nobody, he was on it the other night. This is a 14-inch DSO 14, so he was on Skynet. But then we had the internet problem, and the 17-inch was donated by an amateur in South Carolina, and it's on Skynet, except over the holidays, it's the motor that rotates the dome blew out, and my observatory engineer wasn't able to replace that till last week, and then we haven't had a chance to get it all back online. So we have a couple of telescopes on Skynet, but neither one is appearing on here right now, of course, because our internet's down, so I can't see them. But they're nice. They run automatically and everything. I have enough telescopes, access to enough telescopes, that I am a few years behind getting the data out. I've sadly watched a couple of my binaries published by others, solved by others, because we just haven't had time to do all the reduction. And so I'm not wanting for telescope time. Dr. Smith probably takes all of the big glass time she can possibly get and enjoys it, and well, she should. I'm not a big glass astronomer, as you would call it.
Cool. All right, so well, speaking of Rachel, she has a question. Have you detected any potentially hazardous near-Earth asteroids?
Not me. I mean, I like doing these asteroid occultations because we don't have that much data on the sizes of asteroids. There's a bunch of work that's been done with radar, but that's limited. A lot of that was done with Arecibo, which is now a jumble of trash, which I was told by somebody the other night that Puerto Rico is going to put 8 million into rebuilding it. I don't think you can do it for 8 million. And I don't think they have 8 million. That country's economically in trouble already. So, and I like the observational challenge. I mean, you got to be on one point. There's no second chance. You got to start that. You start the telescope moving, you start the, the exposure. And if you screw up, and I have screwed up, including having jotted down the wrong start time. So it's just fun to do. I think what's going to discover a lot of the potential killer asteroids will be the Vera Ruben Observatory. I mean, when you image the entire sky repeatedly on a cadence of 3 nights, and I think I can't remember the number, it's so impressive. It's 50, 70, 20, I don't know, who cares? Terabytes of data per night. So much data that the plan may still be to drive it down from the mountain in a pickup and hard drives, because you can't push the data through even glass fast enough. Some of the big telescopes that do surveys, they getting it down to the base camp is pickup because you just can't push terabytes over the day. Anyway, I think it's going to discover all kinds of stuff, and I'm hoping that the Starlink satellites don't interfere with it. And ironically, there's a bunch of that kind of, my understanding, a bunch of those observations are right after sunset and before sunrise. Where you want to look is in many cases near the sun, and that's going to be the time when these satellites are going to cause a problem. So
we're almost out of time. So Philip has one last question.
Okay.
When will DSO's next public virtual observing night be? Do you have one scheduled?
Right. It'll be on Saturday, February 20th. So
there you go.
We, I just haven't put that information on the web page yet. I have to. It's a real ordeal to create the web page for the new event. I mean, to add the tickets. It used to be I used a service that was wonderful called Web Connects, and I did it for years with them, and then the bean counters in the university claimed they weren't PCI compliant, which is a purchasing card industry blah 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 blah. And so they made me stop using them, and now I had to learn their TouchNet software, which looks like it was designed by a freshman. And I insult the freshman computer science major in a CS 101. I mean, it's just a clumsy interface, so it takes me a long time I have to clone the tickets. I can't just create new ones. And oh God. Anyway, so I'm going to get that rolling next week. It'll be out there, and normally we also that's not where I want to be. Normally we also have the schedule. So I don't have the schedule out for February because, well, it's not February yet, and we're haggling over those nights. But if you look at the telescope schedule, it's also there. It will be there with a link. So that's another place. So we do these once a month. Sometimes I do an extra event if I have enough discretionary nights. So last week I did a group for, an event for a group of amateurs. So amateur hobbyist astronomy is a big hobby. And so there's a group that centered at Catawba Valley Community College. They have a little observatory. And so they have an event every year they call Bob Fest, named after a guy named Bob. And I don't know the history, but so they let me do a thing for them Friday night, and it went on 3 hours. It was clear, and it just went on forever because I discovered amateurs know stuff. Oh, why don't we look at NGC 1377? That's one of my favorite galaxy. Okay. So it was a lot of fun. So I was able to do that, and did the public night, and I did a night for the ASU Math and Science Education Center on Thursday night. That one we had some clouds that were a problem though. So these dang clouds, we need that. I want Ray's weather to have a button. I've been asking him for years, put me a button that says change the weather, so I can click on that, just change it. That's what I want. But no. So
that would be nice. So well, Maria Clara wants to know if you have a favorite star or planet.
Favorite star or planet? So my favorite planet would be Jupiter, because that Jupiter made me become an astronomer. So when I was maybe 12, 13 years old, and neighbor kid friend down the street was maybe a year or two younger than me, he got a little telescope for Christmas. This is down in Tampa, Florida, and we set it up on his driveway, and we didn't know anything. So we look at this bright thing overhead, and we didn't know what we're looking at, and it was Jupiter, and it had these little 4 dots around it. And then we looked the next night, and they were in a different place. So we had unwittingly recreated Galileo's discovery of the 4 bright moons of Jupiter. And so I got into it and ground polished mirrors and made telescopes and had a rooftop observatory. And my friend Wayne went on to become a geologist and worked as an industrial geologist for Shell, cleaning up old oil drilling sites. At least he was doing something good. And a favorite star, I don't know, maybe nearby Betelgeuse, right, in Orion. And you might be aware of Betelgeuse. Several months ago or so, it dimmed by a factor of 2, and all the discussion was it going to supernova, you know, and Betelgeuse will supernova at some point. It's going to be a very bright, easily seen event, but it didn't. It brightened back up, and all is good. And historically, Betelgeuse has done that periodically. It's just dimmed. So it's a giant, red giant star that's going to eventually try to fuse iron in its core, and unfortunately, it's going to discover, as we all know, that the iron reaction takes energy. It doesn't make it, and so suddenly you pull the plug on the interior of the star. The star collapses, the core collapses in less than a second, and rebounds and blows off. You know, blows off all the material that made you and me and the chair.
Star stuff.
Everything, yeah, star stuff. Yep. Or some of that material.
Okay, I think we do one more question. Liz wants to know, what's your favorite type of galaxy?
Well, my favorite type, it would have to be a spiral. Those ellipticals are absolutely boring, right? Although you have your irregulars too, like M87, where they image the black hole with radio telescopes a year or two ago now. So those are okay, but you know, in fact, I'll throw a freebie in here. Let me close it. Yeah, I want to close it. Let's see. What is it? M74? Yeah, there's a. We took this image. We had moonlight that night last weekend too, and you can faintly see the spiral arms in this. This is M74, the 74th object on Charles Messier's list. But of course, he was a Frenchman observing comets, and he was annoyed by these things that look like comets, but they weren't comets. And he said, I'm going to make a list of things to not be confused with. So he made a list of a little over 100 objects, the Messier objects, the M numbers, and now they're a famous list among astronomers, especially amateurs and hobbyists. They love to look at galaxies, and so you can see some little spiral arms. It was kind of hard to see. I don't think I have another one.
Yeah, I see the one I see the spiral on the bottom.
What's that?
I see the spiral on the bottom.
Yeah. It's I fiddled with it a little bit. I really need a dark correct and everything. These are raw images that aren't calibrated, but you know, we have the Eskimo Nebula. There's one. We'll close out with some. Here's a planetary nebula. This is what our sun's not going to blow up like Betelgeuse. It's just going to puff off its outer atmosphere in a planetary nebula, as it's called. And so it's going to do something like that, or the famous Ring Nebula, leaving a white dwarf in the middle that you can see there in the middle, the hot core of the star. So our sun's going to do this. Put this on your calendar. You know, a few billion years ago, for now, it's going to run out of fuel. It's going to just generally puff off its outer atmosphere, leaving a white dwarf, the hot core, and that's an Earth-size object, that white dwarf, but very hot. So you know, 10,000 degrees instead of 6,000 like our sun right now. So this is our fate anyway. Okay.
All right. Well, thank you so much. What
Okay.
a fun night we've had with you touring around, and
Not bad for a cloudy night with no internet at the observatory.
absolutely, absolutely. Thank you. It's been a lot of fun.
This
So
was great,
I'm
Dan.
gonna.
This was
Yeah.
great, Dan. Just
Yeah,
hearing how astronomers observe and how we all just talk and try to figure stuff out. I think it was very authentic. Thank you for showing
Yeah,
it.
well, and it is. I mean, it's like you'll discover, scientists persevere, and we have to be very clever because things don't go right. And so we made a good thing out of a not so good situation tonight, and that's what astronomers do. Yay!
And a lot of astronomy is fiddling with your software. Everyone
yeah.
has to
Oh my
realize
God.
that. So,
Absolutely. I had
95% of astronomy is fiddling with your software.
Yes, I just had a conversation with my daughter in my 30-minute break today, talking about the scientific method and how if you make an observation and it's wrong, that's okay. That's science too. So,
Right.
I've done those.
Yes, exactly. So, well, thank you, Dan.
Okay.
Thank you,
Yeah.
Rachel.
Thank you for inviting me.
Y'all for watching tonight, and thank you Space Grant for sponsoring us. And if you want an amazing t-shirt or hoodie, see I'm wearing last year's hoodie. They're really, really great. You can go to the museum store, and this is our last program of tonight, but we have a whole day left of astronomy days. So we are going to be going all day tomorrow. So I hope you can join us. And with
I'll be there. I'll be there.
Yay.
Awesome. Yay. Oh, and yes, please fill out our survey, and I'll be emailing that to you too. So if you don't grab that link tonight, if you miss it, it's all right. So thank you. Have a lovely evening, and hopefully you have bright skies where you are. I have clouds.
Dark skies.
I meant dark skies. Yes.
Bright stars.
Bright stars, dark sky, and well, I mean, I guess it's a bright moon too. So.
Yeah. Okay.
All right.
Good night, everybody.
Thank you, Dan.
Yeah, thank you.
Carrie,
Thank you,
everyone.
Rachel.
Bye-bye.
Thanks to the museum doing all
See
this.
you tomorrow. Yeah.
Yeah.
See you tomorrow. Bye.